Greetings, welcome. This is session 5. We are now beginning our journey as a data scientist, right at the point of entry, the data itself. Naturally, we have been receiving the data through eyes and ears and nose and tongues and skin and everything you can imagine in a very natural way. We are unaware of the data coming into our processing unit, which is considered to be our brain. But when we go into the workforce now, it's not something that you have to wait 10 years, 20 years to learn. You need to actually act very fast. The data is actually coming your way quite rapidly, as I'm going to explain. And therefore, your task as a data scientist is not to wait and see. Rather, it is jump on the train, grab the data, understand what the data is, and go through the pipeline. So let me share my screen and remind you of the pipeline. Briefly, in the last recording, we talked about the data science life cycle, and I need you remembering this pipeline. We have the target data, the data is coming, we do a pre-processing, cleaning and everything else. If necessary, we do transformation, and then we do whatever processing that we need to do, including one might be data mining, and then visualization, interpretation, and evaluation. This was KDD process. But we also spoke of a more general way, and that is the team data science process lifecycle, which is mimicking the same pipeline I just explained a moment ago. And that is to acquire the data, understand the data, and then model the data if you must, and then basically deploy the data and see whether the customer is going to accept it or not. In acquiring the data, we need to be very conscious about the data source, the data pipeline. This pipeline means the data pipeline. Is it real time? Is it in a batch mode, a low frequency, high frequency? What is the frequency of the data coming at you? The environment where the data is actually coming, wrangling and all that. And then in modeling, we have feature engineering, we have model training and model evaluation. And then we are going to do deployment. We are going to have performance matrix. And then we are going to send it over after multiple debugging, we are going to send it over to the customer. We spoke of this pipeline, and I really would like you to keep this simple pipeline in your mind. Let's begin the topic 02. We are in session 5. We need to understand the data that is coming at us and the nature of the data and what and how we are supposed to handle them in each case. So structured and unstructured data. It's actually quite simple by the terminology used. Structured means it has a framework. Unstructured means it could be anywhere across the page. So let's begin understanding what that is. Basically, we have, I'm going to get back to this slide after basically I alert you to amount of data that is coming at you. This is per minute. And this slide is potentially rather old, maybe 2015, 2016 timeline. If you take a look at this and other existing map of data coming at you, for example, in YouTube, we have 300 hours per minute loaded by users. That's huge. In terms of tweet, we are going to face 350,000 tweets per minute. If you take a look at, for example, Amazon, you have 4,300 unique visitors, but I would say heavy users would be Netflix, 77,000 hours of video that is going to be streaming. You have Skype meetings, you have Google Meet, you have Zoom, you have Facebook, 4 million posts per minute. And then Instagram, Pinterest, and you have a snapshot. And there are many, many more. TikTok, that is not in this mapping, obviously is rapidly growing. So that's one thing you have to keep in mind, okay? Another snapshot is that if you take a look at your personal computer, you are doing just document, right? You're doing document, you're doing Excel file, you're not doing much. But then the businesses have servers that they are supposed to collect the data. For example, the university organization you're in is supposed to collect the data on their servers, and those data could potentially be student data. It could be Amazon customers. It could be eBay bidding system, whatever you call. And then through the internet, we slowly go into big data and the cloud. Large number of servers are actually entertaining the data as they come in. And then we are exploding in terms of entry points through social media, mobile, and Internet of Things. Again, 100,000 tweets, and this is another old, possibly document, 11 million basically messages. You have 2,000 terabyte data created every minute. This is 60 seconds, and 700,000 Google searches that have been done. And this is really, really big, right? Now, if you take a look at the size that we have, this size is actually growing. Now you need to understand where you are in this universe. In 2010, we only had 20 zettabytes. In 2023, it is projected to be 175 zettabytes. We are not talking about kilobytes and megabytes and gigabytes. We are talking about zettabytes. And this is the way everybody needs to get prepared. The reason data scientists is in demand, because the data coming to the system is actually overwhelming institutions. And that data could be potentially some part sparse, some part useless, some part useful. And institutions want to take advantage of the data as they are streaming in. And that's why you are needed. That's why you need to be here and present and ready to jump onto the train and take care of the data as it is coming in. So let's take a look at this. This is the slide that I tried to prepare and hopefully capture the entire spectrum unit or universe of data space. You have a structured data. If you have an Excel file, you have an Excel file where you have the name, first name, last name. You have potentially basically a student ID. You have phone number, right? This is typically considered to be a structured data. It has a model, and because of that model, you actually created that Excel file. Maybe this Excel file is supposed to represent your monthly expenses. But at the same time, keep in mind, we need to be very clear about the structured data. Structured data is extremely clean. It's like an Excel file with numbers inside, and we have lots of them. Then you go into textual data, as I mentioned, image files that are uploaded everywhere on your personal space, on websites, video, YouTube, as I said, audio is coming in. You have musics to listen to and perhaps upload and let the receiving end enjoy listening to it. You are facing, as the hardware being deployed effectively, and that's a big challenge yet, that this is Internet of Things. You have houses where the sensors are streaming online, the temperature, the humidity, the mobility of the people inside. The garage door is open, the garage door is closed, the doors are open and closed. You have cars with sensor inside. Then you have potentially in the city, you have smart cities where the traffic is actually monitored by the sensors across the road and crossroads, and basically the speeds of the car as they move around. Okay, so keep in mind, we are talking about capturing data through sensors at this time. And then we have JavaScript object notation, JSON, and XML, and all of them are coming in. And then you have metadata. Metadata is rather simple. Metadata is a package. When you take a look at a YouTube clip, you're going to see that this YouTube clip has been tagged. This is data science. This is educational. This is entertainment. So as soon as you say, okay, I'm going to tag the data, I'm going to provide data for data. For example, as I said, the YouTube tagging, you could potentially have documents and you can say, this is a research document, this is a research paper. You can even further tag it with COVID-19. You could potentially further tag it saying that this is in US. You could tag it depending on the university that is actually conducting this research. You could tag the document with so many other, the document to make them, first of all, searchable. Second of all, useful for a person who wants to quickly screen and see whether that document is something that they want to look into or not. Tagging is a very effective way of basically sorting and searching for sorting and searching tools. So metadata is a package. Metadata is a package, but it's a related package. It could be text, it could be audio, it could be video, and all of that come into one specific purpose. Okay, so let's take a look at the structured versus unstructured data. A structured data, you can potentially find them in a database. Most of the time, if the database is supposed to be simple numbers and unique. And of course, in SQL, a structured query language databases, we try to use different techniques, for example, normalization technique, where we are going to make sure that the data entry points are actually unique. So this is a structured data, okay? And then we have unstructured data. This is structured data, as you can see, just to keep in mind, you can see that these colors are well placed. This color is well placed. This is going to be well placed. But when you get to the unstructured data, it's all over the place. What is that? It is going to be your text, your handwritten note. It could be your voice, your mother calling you, your father calling you. It could be a phone call you receive through your cell phone. It could be a chat that you have with your dearest and friends, right? That's going to be structured data. So it is very much a tabular format for a structured data, and there is a relationship between rows and columns, as I said, like an Excel file. We already know what that Excel file meant to be. It has a model, data model. So everything is clear. Do this, do that, do this, do that, very clear. That's why we call it structured data. It's considered the most traditional form because it existed before data science became mainstream. It was as soon as you could potentially have a piece of a paper, where in the olden time, in the old times, 100 years ago, centuries ago, maybe even more than that, when people were using the piece of a paper and a pen and pencil, they would potentially have drawn lines and labeled the first row and put the information on a piece of paper. That's a structured data. And then we had Excel file, and the momentum computers provided us, and that is another basically evolution or revolution in terms of structured data. But in terms of unstructured data, does not have a predefined data model. You talk to your friends and you use emojis and you use abbreviations and encrypted text that only you and your friend understand. You could potentially talk to your friend using your cell phone, using WhatsApp, Telegram, Signal, or whatever social net that you're using. And when you're doing this, you have no idea what you're supposed to be inside a structured environment. No, you just simply talk. You want to have fun. And then you have audio. You start listening to a music, and that music depends on the nature and the type. It could be even not a regular structured poem that you are going to listen to, okay? It's typically text heavy, has audio and video files, and we call them not only SQL database. NO stands for not only. NoSQL also works if you want to read it that way, but it means that it is not only structured, but also unstructured. So that's what we have. And then we are going to use different tools. We have optimization tools such as MongoDB, Apache Giraffe, and so on. And then we are basically gearing, as you have seen from the graph, we are gearing toward big data, because the amount of information that is coming in is usually unstructured. The huge amount is unstructured data. A structured data, I mean Excel file. How many of you have an Excel file these days? And how many Excel files do you have anyway? But how many of you actually talk and and text and listen and watch? You see, so that's the big challenge. Let's have some comparison between structured and unstructured data. This is going to help us connect in an emotional level with the two topics, with the two terminologies. Basically, structured data, they are predefined data models. Usually they are in the form of text, like a birth date, like a cell phone number. Easy to search. It's very easy. So for example, if you say that the area code is going to be XXX, really you can easily find what that area code and the people associated with that area code are. It's very easy to search. Even among 350 million Americans, or even globally, you can easily search. We are talking about relational databases. We basically could potentially still have huge amount of them, but not as significant as unstructured data. And these are still residing in data warehouses. Warehouse, as you know, you have seen warehouses in the past. Data warehouses is a specific place where you are going to store the data. Usually they are generated by humans, or potentially some machines, not all machines. So the reason I'm going to separate this, and I say mainly humans and a few machines, is that as I go into unstructured data, it is mainly machines, if it is IoT, Internet of Things, and it could be human as well, such as talking and texting and all that. There is no predefined data model. You wake up in the morning, you do something strange today, which is not even the same as yesterday. Maybe text, image, sound, video, or other format, difficult to search, not easy. Of course, we are going to find some solution, and we are going to discuss that in other courses. But at this time, if you give me your daily activity, I'm going to have difficulty understanding what is where in that sense. Resides in application, and not only SQL databases, data warehouses, and data lakes. That's where they are. Let's take a look at typical application, structured data, airline reservation system. You go from A to B on date, flying out and flying in, two-way ticket, things like that. It's very clear, very structured. When you want to buy a ticket, everything is clear. Inventory control, you want to know exactly what it is in each of the stores. You want to know which box is where, in Best Buy, in Walmart, in whatever store that you have in mind. We have different systems. We are not talking about those at the time. Examples, as I said, dates, phone numbers, social security numbers, credit card numbers, customer names, and transaction information, such as Amazon.com. If you go Amazon. Whatever country you're in, and then you could potentially enter this information to perform a task. But keep in mind, the size of the database in Amazon is not 8 billion people. It's not 350 million people in America. It's just the people who are going to be using it, and there may not be, some of them may not be even using Amazon. And even if they want to use it, it's going to be as simple as half a page of information. It's really small. In the unstructured data application, word processing, you type a sub-presentation, PPT, email, tools for viewing or editing media, right? Now, examples, text files, reports, email messages, audio, video, and images. I hope now you can see the difference between a structured and unstructured data. Now, you might say, listen, can you please help us to alleviate the pain of an unstructured data? Yes, we can. And the way we are going to do it, we are going to actually combine structured data and unstructured data and make it a little bit easier to search, a little bit easier to process. We are going to call it semi-structured data. Okay, it's a form of a structured data that doesn't conform with the formal structure of a data model, but at the least, it has tags and markers to separate the semantic elements. I'm going to show you an example in a moment, such as the JSON, JavaScript object node. Basically, we are going to see it in a moment, okay? Notation, yes. So this is a JSON. If you take a look at this, you see version, it's going to be the same. Whether you are the one entering the information in the yellow, in the red component, or someone else is going to do it, the fact that this place is dedicated to version, it means it's structured. The fact that you say default provider is CD and default provider is there, that means it's structured. But you could potentially say CDNJS. You could potentially say AXBFYZ, right? Provider unpack UNPKG. You could potentially change that to AMZ or anything you like. Library, as you can see, I'm using @ signal. I'm using the slash signals. Destination, I didn't even put the proper website address. I did make a mistake. Keep in mind, the data that is coming in is not necessarily a correct data anyway. And one of the challenges you're facing is to clean it up. So if I meant this to be www/root/lib/, it's your job as a data scientist to basically take care of that. And then I'm saying files here. But why do I say it as structured? Because I have forced the format: version, default, provider, libraries, provider, library, destination, files. Why is it called unstructured? Because the user can potentially do whatever they want. They can even put signs and words that are not supposed to it may not even make sense. So that's why we have unstructured living side by side with a structure, with a template in front. So that's why we call them semi-structured data. This is another example. You have a tag, and then you end the tag, and the way you do it. So I'm going to say configuration is just there. A startup is just there, and then supported runtime, and you go and you put in the different information, attribute name, attribute value, and everything else. But keep in mind, this structure is not yours to decide. If you are actually writing XML, extensible markup language, if you're doing XML, this structure is not yours to decide. But you could potentially put things that could potentially provide error at the end of the day. Why this is useful? Because, well, if I wanted to find configuration, it's very easy for me to find the place for configuration. Then it would be my challenge to go in. Instead of looking at the whole jungle of the information, data that is coming at you, you have some sanity inside. The sanity is, listen, this part is configuration. Listen, this part is basically libraries. This part is provider. Go and check it and see whether the user has actually put the information correctly in the system or not. That's why we call this semi-structured, okay? The next topic is a slightly different, so I'm going to begin on that on a part 2 of session